Hi everyone, this is Kenny Lee, and I want to talk a little bit about how to solve circular motion problems today. So first, let's kind of go over some things. Period is how long it takes for it to go through one rotation or one revolution. And we usually use that as a capital T because it's a very specific time. It's the time to complete one of something. Even though things are going around in a circle, we usually use the linear velocity, or we can just say speed, of the object, and that's simply how fast it's traveling at any one point. And that's in meters per second. Another type of speed or velocity is angular or rotational velocity. And it uses, instead of a v with like linear speed, it uses a lowercase omega. And again, it's how fast an object is turning, but its unit is radians per second. So meters per second is the linear speed, radians per second is the rotational speed. Then centripetal acceleration, it's that inward acceleration that's causing it to go around a circle. And correspondingly, there's centripetal force, which is the inward force that makes something go around. So when you move something to make it go around a circle, you push in on it. You don't force it out, you push in constantly to change its direction. So what actual equations are we going to use? It's basically these here, where period is just simply the time, the total time divided by total laps. So we want just the time to go around once or rotate once. So we just simply take the time divided by how many times it does it. Linear velocity, we take the circumference and divide by the period. And that r is for the radius or distance. Depends on how the problem's set up, but usually it's just the radius. Centripetal acceleration is v squared over r. And centripetal force is just F equals ma again. Centripetal force equals mass times centripetal acceleration. So let me throw you into the deep end right off the bat. This is the longest problem that could be asked on this topic, usually, unless we mix in other disciplines. We've got a 0.6 kilogram ball at the end of a 7.5 or 0.75 meter long string. If the ball goes around 20 times in 5 seconds, what's the ball's period, velocity, centripetal acceleration, and centripetal force? So first, it's on the end of a 0.75 meter long string. So you're holding one end, the ball's on the other, so it goes around a circle like this. So that is the radius, okay, is 0.75. First thing we want to do, and I call these circular motion problems paint by numbers type problems because they all follow a certain pattern. They all go from period to velocity to acceleration to force. But you may jump on a different place, like you may already know the velocity, so you just find the acceleration and the force. Or you have the force, and then you find the acceleration, then the velocity, then the period, or something along that pattern. It's all pretty much going back and forth. So this one, we're first going to figure out the period. So it goes around 20 times in 5 seconds. So 5 seconds is the time, and it goes around 20 times. And so the period is 5 divided by 20, 0.25 seconds. All right, so it goes around once every quarter of a second. So now the next step is to find the velocity. So velocity is the circumference divided by the period. So 2 times, and it's okay to just use 3.14. You don't have to use the pi button. If you do, that's okay, but 3.14 is usually pretty good. The radius is 0.75, and the period is 0.25. So we get a velocity of 2 times 3.14 times 0.75 divided by 0.25, 18.84 meters per second. All right, keep plotting along. So now that we got the velocity, now we can find the centripetal acceleration, v squared over r. So 18.84, and that's squared, divided by the radius, which is 0.75. quite frankly, in most of these problems, finding the period is actually the hardest part. After that, it's mostly just plug and chug. So we've got 18.84 squared divided by 0.75. We get an acceleration of 473.26 meters per second squared. All right, which is a lot since the acceleration due to gravity on the Earth is 9.8 meters per second squared. So that's pulling a lot of force right there, or pulling a lot of acceleration, I should say. And then find the centripetal force on it. Fc equals MAC. Mass was 0.6. Acceleration was at 473.26. 473.26 times 0.6 gives me a centripetal force of 283.9, let's call it 6 newtons. But that's the longest problem of this type that's usually asked. So what happens if we pick it up in a different spot? So let's look at a different one. Okay, on this one, we've got an 800 kilogram car goes around a circular track that has a diameter of 100 meters. If the car keeps a constant speed of 30 meters per second, what's the centripetal force on the car? All right, well, let's see. We first need to figure out, do we have to actually figure out the period for this one? Well, no, because we actually are starting off with the velocity. So we start off already knowing what the velocity is. So we don't need the period and the circumference to figure out the velocity. We already have that part. So we only need to find, well, to get the centripetal force, we need to go centripetal acceleration and then find centripetal force. So we need to only do those two steps. Okay, so AC equals V squared over R, because we already know what V is. So that's 30 squared over R. Oh, watch out for this. I gave you the diameter. So the radius is going to be half that value. So 50. So 30 squared divided by 50 gives me an acceleration of 18 meters per second squared. And now I can find the centripetal force. Okay, so mass is 800. Centripetal acceleration is 18. So 18 times 800 gives me 144.00 newtons. So 14,400 newtons. Now what's causing the centripetal force? Well, that's actually friction. Remember, centripetal force is not a force in itself. It's a renaming of another force. So in this case, it's the friction between the road and the tires that's pushing inward on the car. If that friction was to disappear, the car would go shooting off in a straight line and into the wall or whatever the barrier is. Now, we've been going kind of this direction through these problems. Well, if we try to go the other direction. Let's look at this one. So we like to have things on the end of a string. So we got a 0.4 kilogram mass on the end of a 1.2 meter long string. I have a force sensor that says the tension is 60 newtons. Now again, remember circular motion and centripetal force. Centripetal force is a renaming of another type of force. In this case, it's tension. Whatever force is making something go around in a circle, we name that force centripetal force. It may actually be a tension, friction, the force due to gravity. It could be any of those things, but if it makes something go around in a circle, we can then name it a centripetal force. And we want to know the period of revolution for this object. All right, so this time we have to go the other way. We know the force starting off. So we know Fc equals MAC. So we know the force is 60 because it's newtons. We have a mass of 0.4. So we can solve for acceleration. Divide both sides by 0.4. And we get an acceleration of 150 meters per second squared. All right, so we got that part. So the next would be going through that process. We got period, velocity, acceleration, force. So the other way is force, acceleration, velocity, period. And so we've got AC equals V squared over R. All right, so AC is 150. We don't know the velocity, but we do know the radius is 1.2. Okay. And so we will get times 1.2, 180 equals V squared. But we don't want V squared, we want V, so we're going to have to take the square root. And so velocity is 13.4, let's call it 2 meters per second. Then to finish it up, we need to figure out period. Well, velocity is 2 pi r over the period. So we need to solve for that. So velocity is 13.42 pi 3.14, and radius is 1.2. We got to figure out the period. Super secret metric. Period comes out and that takes its place. All right, so we got 2 times 3.14 times 1.2 divided by 13.42 gives me a period of 0.56 seconds. So it goes around once every, well, little over half a second. All right, thanks for joining me on this one, and tune in again for some more physics. Bye.